right, Mr. H here. We are going to be playing today with the Unit 4 review. Now, yes, it's chunky. I understand this, but it is not going to be that chunky on the exam. The exam will be about half the size. So the review, I think, is 28 or 29 questions. The tests will be around 15, 16, somewhere in there. So what I'm going to do is we're going to just jump in here. Now, the goal of this was that you were to be working on this on your own and then using this as your excess, okay? Using this as your extra help if you need it for something. Or maybe you look at it before and then you try to do some. I don't know, but just saying. Okay, find the sum of these. Sum just means add. So I'm going to find my like terms. So my 4x squared and my 7x squared. And I would have my 11x. Now, if you need the squareds, here is my little, move this down a little bit. Here is my exponent button. So the 11x squared, 3x plus 7x, it would be a plus 10x, and 2 plus 3 is 5. You're like, shoot, are you going to make them all this easy? Maybe. We'll kind of see here. So that one wasn't bad. Not too bad. Now, with the minus, remember that minus is going to distribute to each of these. So this is 8x squared minus 6x squared, which would be 2x squared. Okay. You also can use that little shift 6 to get that little caret button. That'll also get you the exponent if you don't want to play with all of these. Negative 7 minus, ooh, careful. What happens when you minus a negative? It becomes plus. So negative 7 plus 1 is a negative 6x. And then distribute the negative one more time. And again, if you're one that tends to have some issues with problems sometimes, with signs and things, do it on paper. Some of these problems I'm going to be doing on paper as well. So not a bad idea. So I have negative 3. So negative 2 minus 3. Oh, $2. Oh, 3 more. Minus 5. Submit. Other nice thing is if you're feeling comfortable in some sections, you can skip around here. I mean, that's not a big deal either. So perform the operation. Again, it's adding. So find the like terms, negative 5 and negative 4, negative 9x. Let me get my squared. Negative 4 and negative 4 do not cancel. If I owe somebody $4, then I owe them 4 more. My bill is not paid. Minus 8x. And then there is no other term to be combined with my minus 1. So I just put in my minus 1. Go about my business. Okay, so hopefully that section was pretty easy for you. All right, multiplying polynomials. Now this is where we're gonna do, no, we're not gonna do that. Already's gotta move things around a little bit here. Maybe. Aha, that's why I didn't see it was hidden. All right, now we're back at it. So we've talked before about when we have these about making a box. Okay, if you are a distributor, you go ahead and distribute, but I'm more of a fan of the box, and I also need to, that's, in some ways that's better, in some ways that's worse. All right, x plus 2, 3x squared minus 7x minus 4. So remember, here we're multiplying coefficients, okay? We're adding exponents. So 3x to the third, 1 plus 2. 7 times negative 1 is negative 7x squared minus 4x. 2 and 3 would be 6x squared. 2 and 7 is negative 14x. And I just work my way through. And once I get there, now what I'm going to do is I'm going to go through and combine my like terms. But I'm going to write it in standard form, meaning I start with my greatest degree and work my way down. We're no longer multiplying. 6 minus 7 is negative 1, or you could just have negative x squared. 14 minus 4, oops, negative 14 minus 4 is negative 18x minus 8. So to me, that is the answer that I want. So I am going to do 3x. Now, notice I don't have it to the third here. So I use that AB button, And that will let me put in any exponent besides 2. So if I need 4, 5, whatever, I just use this AB button. So then we got a right arrow, because you see it's up in the exponent still. Right arrow, minus 1x. We're going to test out if it doesn't like the 1 or not. If it doesn't, we're going to know not to do that when we get to the test here later. All right, are we the same? I think we are. Still likes me, okay? Even though it would rather have just minus x, minus 1, perfectly fine. And look, they used a box like me. What a brilliant website. Knew I liked it for a reason. All right, so next one, okay? Same idea. Same idea. So on this next one, here, you know what I can do? I didn't think I was going to do this, but you know what? I will. On this one, I'm going to go ahead because some of you may be distributors and you feel left out. So if you're a distributor, 3x to the third, add my exponents. It's just like doing the box, except you're just doing it with arrows instead. And for me in this case, if I was going to go that route, I would use different colors because that way I would not forget about part of this because that would be kind of important. So mainly here, just watching for our signs and stuff. And so I get here and I'm like, all right, let's see. 3x to the third. That's my only cubic. So that's there. So let's see, minus 5x, oops, positive 5x squared and negative 9x. Negative 4x squared. Negative 7 minus 15 is minus 22x plus 21. Hang tight for just a moment. All right, so let's see here. We have got 3x. Oops, let's try it again. 3x. My keyboard back up here, little guy, to the third. Down. Minus 4x squared minus 22x plus 21. All right. Think we're good? Yeah, buddy. All right. Now, polynomial, notice, long division. Now, I'm not going to be a stinker on the first one that I do with these. I'm going to do one first before I start doing shady stuff. So, okay, so x plus 2, 4x cubed plus 11x squared plus 16x plus 20. Okay, this is when we were doing our side work. These were the ones, let me zoom in a little more here, where we did first term divided by first term first. 4x cubed divided by x. And whatever we get for that answer, okay, that goes up here first. And then whatever answer we got from number 1, that's what we're going to multiply times our divisor. So we're going to add our exponents. We're going to multiply our coefficients. And this is the value that we're going to stick under here. Now, in talking to the classes differently and talking to some people, what we used to talk about doing was putting the minus over here and changing the signs. Okay? And people got to feel that's kind of sloppy. I'm really not a fan of that. So here's what I would suggest the other option. Once you get this answer, change the signs on both of them, whatever they are. So if they're positive, make them negative, negative, make them positive. And then just write them over here that way. Because at that point, you don't have to worry about the whole add, subtract thing. You're just going to be adding down. Okay? First terms will always cancel. 11 minus 8 is 3x squared, and I'm going to bring the rest of my terms down. And I'm going to start over again. So I go again, and I go, okay, first step. First term divided by first term. 3x. 3x. Nice thing about a video, you can pause me, you can rewind me. Hey, what's better than that? You wish you could do it in real life, I know. Multiply it times our divisor. That never changes. 3x squared. No, I didn't. I'm sorry. So again, like we did before, sign change before we move them. Hold on just one moment for one more slight break. So, all right, we're almost there. You're like, almost there? Seriously, Hardy? Yeah, seriously, almost there. Well, what do we still got to do? There's still an x left here. So one more time. Last time, 10x divided by x. The x's cancel, leave me 10. You're like, see, you can't even fit it. I'll make it work. X plus 2, 10x plus 20. Again, change signs. Negative 10x minus 20 is a big fat 0, and we're done. Now, I'm going to have some really good news for you here in a minute. And this is only going to be for those of you that actually worked through and listen to the video are going to know this. So just a second. So 4x squared plus 3x plus 10. I want you to take note of one thing. Oh, I'll do it after I submit the answer here. Okay. I'm going to be straight honest with you right now, you and me. Greatest thing ever. Do not tell your friends that aren't watching this. I'm never going to know if you use long or synthetic division. Okay, that's all I'm going to say. X plus 2, what would you put in a little box? Negative 2. Do the synthetic. Put your variables back at the end. You're going to get the exact same answer. I didn't tell you that, though. I didn't tell you that. So with that in mind, I'm leaving the next long division one for you to do because you know minus 1 goes in the little box. So all you would do is this. Minus 1 in the little box. Oops, probably helps if I'm on the screen. Are there any gaps? 3, 2, 1, 0. Nope. 3, 13, 11, 1. Do your synthetic division and get the answer a whole heaping lot faster. I started with what? Degree 3, degree 2, degree 1, degree 0. Boom! Seriously, it's worth it to know what you're doing on this stuff, people. It's worth it to put the little bit of time in to know little tricks like that instead of struggling, and then somebody's going to write to me as they're doing this and go, Hardy, this is too long and I don't understand, because they never watched the video and they never did any of the work. So you know these little tricks otherwise. So here, what's the result when it's divided by this? It's exactly the same as I just did here. I don't need to do another one. 5 goes in the little box. And then 3, negative 17, 12, and negative 10. You put them in here. So Hardy's going to give up on this one. Yep, I'm giving up. I need to get on to bigger and better things. Okay, and then same thing here. Minus 5, positive 5 goes in the box. Put the things. I cannot give up. They will not let me give up. They won't let me. Okay, well, then I guess I got to do this one. So 5, 3, negative 17, 12, negative 10. And remember, you've always got to check to make sure there's not gaps. These should always go down by 1. 3, 2, 1, 0. I don't know why I'm so off here with this, but pull down the first one. Multiply that by what's in the box. Put that in the next slot. Add down. Multiply that by what's in the box. Add down. Multiply by what's in the box. Add down. If there is something here, that would be my remainder. That would be something x over 5, but I mean, there's not this time. Just saying. And again, we started with a degree 3, degree 2, degree 1, degree 0, which is my constant term. Let's try something out here. Check that out. The little up arrow does work for those of you that were wondering at home. I'm sure you were. Rolling. All right. Synthetic division. Negative 7. Okay. Again, everything else, just roll with them. They're going to let me give up. They're not going to let me give up. Well, this time I'm just going to be Oh, I can't even spell give today. That's why I'm not an English teacher. Now, don't you do that. I will not find that funny. Now, in the review, you're going to get multiple options at trying. Okay? During the exam, you're going to get one extra chance. I got to take that back. Okay, yeah, I missed. Well, you know. Now, here's where some of you are going to look at this and go, wait a minute, what is this? If f of x is this and x plus 1 is a factor, then find all of the zeros algebraically. Okay, that's just a fancy way of saying switch your sign. Okay, that's no different. I don't see any gaps. So 1, 14, 43, and 30. Pull the 1 down. Multiply by what's in the box. Add down. Multiply by what's in the box. Add down. Multiply by what's in the box. Add down. Now, hey, don't have a remainder. That's good. Put my variables back in. Squared x and a constant. Now, to find the zeros, they want answers this time. They don't want just this. Don't write that. That's not going to help you at all. If they ask for zeros now, I've got to take x squared plus 13x plus 30. I need to use the quadratic formula. If I did that, my a would be 1, my b would be 13, my c would be 30. We did that in the notes before. I'm not writing that again now. You need to find it if you need it. So as you're going along with the, so we've got the quadratic formula. If this was something else, I'd say algebraically, but man, that screams factoring to me. Multiply and add. Now again, I don't even have to worry about clues this time because everything's plus. So multiplies to 30 and adds to 13. Now maybe I got to play with my calculator for a little bit. That's not a big deal. But multiply to 30, 10 and 3. Now is that what they're asking for? No. Find the zeros. They're like, we want the answers. X equals. Okay. So each of these would equal 0. And if we solve them, we get these. But remember, they already partially gave you an answer. When they said that x plus 1 was a factor, okay, we set that equal to 0 too. Now we already know that it's -1 from right here. But those are the 3 answers that we're looking for. And as we've learned from our adventures with putting answers into DeltaMath before, we don't need the x equals. So -1, comma lets it know, hey, I'm done with the first answer. Here comes the next one. -10. Now, if that was it, I'd hit answer, but I have one more answer. So one more time, again, hit comma, put in your last answer, okay? Somebody told me earlier the x's work, and that's fine, but I really don't feel like messing with that. And that's how that would work, okay? So you've got to keep kind of playing with these. Now, this one is doing this same type of thing. I'm not going to do the whole thing, but I am going to set you up, even though we did this when we were talking about the fundamental theorem of algebra DeltaMath sheet. What would I do here? When you see f of -2 equals 0, they're giving you one of the zeros. They're giving you that one of the zeros is -2. Whatever number's in the parentheses is an x. So when you go to do your synthetic division to do the rest of the problem, the -2 is what goes in the box because it's not parentheses this time. They're just giving you the value. You didn't have to do anything. And so for the rest of the problem, I'm going to be quiet. I'm not going to do anything because I want you to have to actually work at some of these. So, and you've got an example to do one from the last one. So again, I rock at algebra. Oh my, what was that? Algebra. That was just weird. I'm okay with it though. And I'll take up my other turn as well because I want you to actually do some of these, not just use mine. Okay. So, okay, we ended up losing that one. That's okay. Okay, so given the definitions of f of x and g of x, find the value of g of f of -1. Yes, we are back down that road, ladies and gentlemen. It's been a little while. G of f of -1. we are working just like we did before, right to left. Find f of -1. In other words, plug in -1. Oops, except that's minus. See, those are those things you got to watch for. I do too. Get going here, and then I mess things up. So I just plug the -1 into f. You can plug that right into your calculator if you wanted to. I'm not going to. I kind of want to do the problem here. So, okay. So that gets me my first answer. But now I got to plug it into the last function, which is g. So my last job is to do g of 6. So where's g? 4 times x plus 4. Because as we were saying a couple sections ago, the number in the parentheses is just my x. 24 plus 4 is 28, I believe. Yes, I do believe that is the answer. Rock star, that's me. Okay, and then this next one really is the same thing. We're going to do another one where we're going to look at the way it's written. No different than what I was doing up here, except for the number. -3 goes into f. And another way you could be doing this, I'm sorry that it's a third of the way through before I thought about this, you could start to do them on your own and then hit pause and watch me do it. I mean, that's an option. So 4 times -3 plus 8, -12 plus 8 is -4. And we still work our way out. So g function, -4, -4 squared plus 2 times -4 plus 7. And again, type it into the calculator if you want to. I don't care. I think we got 15. It's always going to be that second answer on our compositions here. Roll in. All right. Evaluate. Find f of -1. Literally just plug in -1 where x is at right there. So 3 plus 16, I believe, is 19. And again, do take some time as you're going through. If you've done this on your own and you're watching this later, or even if you're watching it now and you're going to go back, pause me at a time or two, but just watch what they do. It's like having the work all written out so you know what's going on when you go back to do this on the exam, because you're not going to have me chatting with you the entire time on the exam. So given that f of x is this and g of x is this, find f plus g of x and express the results in standard form. You know what that's a really fancy way of doing? What we did on the first 2 or 3 problems. All it's saying is combine like terms of these two functions. So I look around and I'm like, okay, I see x squared. I don't see any other x squared. So x squared. I got 6x and I got 1x. Remember, there's a 1 in front of there. 7x. And I got -40 plus 10, which is -30. That's it. It's the same thing. It's just in a different notation, and I'm trying to see if it messes you up. Okay? Given that, f minus g of x. Now this one I'm probably going to write out because that minus can screw things up so bad because it's the whole quantity we're subtracting. That negative is distributing to both of these and changing their signs. It doesn't change a thing on the first part though. So now that I'm here, I can get there a little bit easier. X squared, -3 and -1 is negative or minus 4x. -10 plus 5 is minus 5. Don't let that stuff mess with you. All right, let's see here. Rewrite the following in standard form. All that means is biggest to least. So -4x. Again, shift and 6 will get you to the exponent if it's not giving you that as an option here. And for some reason it is not. Minus 10x, shift 6 squared plus 5. And we're rolling. All right, using the graph. All right, let's make this big for a minute. Using the graph, tell me the domain and range. Note, INF is infinity, okay? Domain and range. Domain. X values from left to right. Let me just tell you something. When we're dealing with polynomials and we're dealing with domain, it's infinite, period. Forever to the left, forever to the right. So that gets it down to one of these two answers, because these are the only ones that are negative infinity to infinity. So last two, range. Y values bottom to top. I see they're going up forever. Doesn't go down forever, though. It only goes down as far as 1. Ooh, things getting screwy here. Now they've got a boo-boo here, because this is definitely 1 to infinity. So it's not this one, because that should be 1. That one's got 3. Note to self. Domain and a range of polynomials. Yeah, that's definitely a problem, because that should be 1. That is not 3, because this is not range. So I'm going to submit answer, and it's probably going to tell me I'm wrong. Oh. It should have told me I was wrong. Oh, yeah, I'm going to have to get into that one. Oh, dear. All right, let's try this next one. What's the domain and range of this polynomial? Okay, we already said about domain. So it's one of these two. Okay, now range. Now this one we got to watch, because I look and I'm like, well, the lowest point down here. Okay, so let's see. Lowest, highest, no, but that'd be range again. Oh, here's the key this time. Okay, we got arrows. What do arrows mean? Arrows mean infinity, right? Down forever, up forever, all the infinities. This one I feel good about. All right. So again, we just got to watch for some of those things. Okay, factor. Oh, factor. Other page, back up. Okay, here again is where we need to remember or go to our notes. Now again, that's your call on what you've been doing with notes or not, but I'm not going to give you another sheet now telling you what all the things are. You're going to have to go back and look at your factoring stuff if you need on these. So here I notice these are both perfect cubes. I cube 3 to get 27. I cube 5 to get 125. And I cube b to get b cubed. Now, as far as the form goes with this, I'll show you the generic form, and then we'll kind of fit it in here. So for a sum of cubes, it would look like this. So when I go to fill it in, this is my A, this is my B. So A plus B, and then A squared. So I'm going to actually write this out so you can see what I'm doing here. So A squared minus the product of A and B, and then plus B squared. Now I can't leave it this way. It won't tell me the answer's right if I leave it this way. So I'm not going to mess with the first set of parentheses. This next one, so I got 9, negative 3 times 5 would be negative 15b plus, be careful, square goes to both of these, 25b squared. All right, let's see what we got here. 9 minus 15. Taking a gripe if I use x instead. Well, I guess I can use b. Oh, yeah, I have b. Why wouldn't I use b? Plus 25b squared. Submit. Yes. Your answer is not correct. Oh my gosh. Some of you are laughing at home, aren't you? Admit it. You're chuckling. You should. Artie, you didn't write the whole answer down. You're right, I didn't. Back to the beginning here. I got to have both pieces, don't I, if it's going to be a... Okay, 3 plus 5b, 9 minus 15b plus 25b squared. Okay, now that I actually typed in the whole answer, let's try. That's better. That's right. Difference of squares, okay. The only difference on difference of squares is that it's a minus b, a squared plus ab plus b squared. The difference is those two signs switch. Everything else is the same, okay? You've got your 2s for your a term. You cube 2 to get 8, and s to get s cubed. And we just got done saying you cube 3 to get 27. Plug them in, multiply like I did up above, get your answer. I'm going to purposefully be a goof. 2s minus 3, go. I'm answering, no. Well, I think you're wrong. It's 2s minus 3. Well, dadgummit. And again, yeah, not right. Part of it was, but not. Okay. Factoring by grouping. Again, you've got notes and examples of this if you've done those things before. But if you haven't, and this is your first shot through, I will give some assistance. When we have 4 terms, when we're grouping, we're going to pair them off. And within each of those pairs, we're going to find the greatest common factor, what they have in common. So I'm going to forget about that one for a minute. And I look at this one and I go, okay, 2x cubed and x squared, they both have x squared. When I'm looking at numbers and variables, the variables, I'm looking for the smaller exponent that they have in common. And for numbers, I'm looking for the biggest number that goes in. Okay, those two things. So once I pull that common factor, okay, what do I have to multiply this by to get to here? Well, I see I don't have the 2. And to get from 2x's to 3, I need one more. You can put the 1 on there if you want to. Now here you're going to tell me, Hardy, I don't need anything. It's x squared and x squared. You do need something. You got to have something. What do you multiply something to get itself back? You multiply anything by 1, you get it back. You have to have something there to hold the place. Don't tell me nothing. And then we do the same thing over here. Okay. What goes into 22 and 11? Play with the calculator if you need to. If you need to, you're like, I don't know what goes into 22 and 11. Oops, hang on. I got to get out of there. Oh, 22 and 11. Oh, 11 goes in. Okay. Minus 11, since they're both negative. Negative 11 times what gets me negative 22? 2. I don't have the x. Negative 11 times what gets me negative 11? We just had this conversation, I think. Here's the key, though. If you do this right, these parentheses are going to be the same. If they're not, if a sign's off or something, go back and look. But those always have to be identical, because when you go to write your answer then, it's putting together your greatest common factors, the stuff on the outside, and then one pair of the common set of parentheses. If this would have been a perfect square, like let's say this would have been 4 or 9 or something, and I can break it down more, I should. But since 11's not a perfect square, that's as far as we can go. So let's get this in. We got x squared minus 11, close, start again, 2x plus 1. And so that's the game we keep playing here. So we'll play it one more time here. Or I would prefer, in this case, that you would pause me and do it yourself before you would just watch this aimlessly. Because I do have kind of a caveat or a warning at the end of this video I'm going to need to give you. So, all right. Forget the second one here for the time being. Again, nothing goes into 2 and 3. Okay, we got x squared again. I need the 3. I've already got 2 x's. I need the third one. Here, I need the negative 2. I got both the x's already. But this time I remember, okay, I kind of have a clue in my head. I know the parentheses better end up as 3x minus 2, so we'll see. Anything that goes into 18 and 27. Now, again, you want it to be the biggest number. Because you might look at this and go, hey, 3. But then you try 3 and your parentheses don't work. Let's try bigger. What's bigger that goes into 18 and 27? 9. But here's the key. You're like, well, one's minus and one's plus. What sign do I use? Let the problem guide you. 9 times what would get me to negative 27? Negative 3. Uh-oh, that's not going to work. I want this to be 3x. So the 9 has to be negative, because negative 9 times 3 would be negative 27. Now let's make sure. Negative 9 times what would be positive 18? Negative times negative is positive. So you can work that through. And isn't it a coincidence what happened here? X squared minus 9, 3x minus 2. If you put this at the answer, it's going to tell you you're wrong. Now, it's partially wrong, but it's still wrong. Why? Because this, ladies and gentlemen, is still a difference of squares. I can square x to get x squared. I can square 3 to get 9. So that first set of parentheses, I can do first plus second, first minus second. And I have a very large suggestion for you. If you haven't done anything with the notes, if you didn't get them picked up or anything, you need to go back a couple of weeks to where we did the advanced factoring and print off or jot down that note sheet of what these forms are. Because otherwise you're going to run yourself into a problem. So x plus 3, x minus 3, 3x minus 2. All right, we're almost there. We're over 3/4 of the way home. Find the inverse. All right, inverses. Do we remember inverses? We're going to find out. F of x equals 3x minus 8. First thing, f of x is a fancy way of saying y equals. Second thing, when we do inverses, we switch the x and the y, and then we solve for y. So we're going to solve for y. We're going to get this 8 out of here. And then we're going to divide by 3. Now, okay. Now, luckily for me, I see I get multiple choice this time. That's a nice, happy sight to see. Watch for little things. Don't go so fast. It's going to be tempting for you to click on this first one. And why would that be bad? Because that says x equals and it has the y over here. That's not, we got y equals. So it couldn't be the first one anyway. So make sure when you're looking, little things. Or I put one in here that there's a minus 8. Ooh, what a rotten dude. Not rotten enough that I didn't give you, multiple choice on a few of these. That never happens on DeltaMath. All right, y equals 2x minus 7 over 4. Switch x and y. And some of you that haven't done anything in a while, you're like, dang, we've done a lot of stuff. Yeah, so you got to hunker down here. Okay, first job, let's dump the fraction. When we multiply by the 4, it does not distribute. It just gets rid of the fraction on this side. And now it's pretty close to what we were doing in the one above. Add my 7. Divide by 2. Okay. 4x plus 7 divided by 2. I think that's it. No. See, that's if I'd have distributed that 4. That's bad. I have no idea where that would have come from. And again, the whole minus trick. So your answer is not correct. What? All right, Hardy's got to go back and look. I did something. 2x minus 7 over 4. X equals 2y minus 7 over 4. Multiply by 4. Add 7. Divide by 2. I'm hoping somebody out there is screaming at me right now going, okay, I'm curious. I want to see what they did here. This is why we keep an eye on DeltaMath. Okay, that's just flat wrong. I'm going to make a note of this. Find the inverse. I'm at least going to put a different problem in there. So if some of you are telling me, I'll be like, oh yeah, we're going to have to chat on a couple of these. Life happens. It does. All right. Determine the domain on which the following function is increasing. Okay. Domain is x values. Okay. Increasing. Where is it going up? Well, from here until I get to my maximum right there. So it's increasing from negative infinity, because I'm starting here at the left. Again, domain is x value. What's the x value at my peak right here? -2. Now the question then becomes, are you doing parenthesis or bracket? Now I want to see if it's going to get tricky with me on this. See, this is where we're learning this stuff. Okay, now my theory is it didn't like my parenthesis. It wanted a bracket because that's the actual value up here. It does say increasing. Okay, now Hardy is interested. Okay, x is less than -2. Again, we love DeltaMath, right? We love DeltaMath, but we're learning something. DeltaMath just wants it to be x is less than -2. It just wants me to know it's from there on here. Negative infinity to -2 is the same idea. It's a formation thing. So if you would run into this on the test, now hopefully we remember this now, because this isn't that their answer is wrong and that theirs is wrong. It's just a different way of writing it. That's x is less than -2. They just want to know what piece it's in. But if you do this, screenshot me, we'll get it right. Okay, now we know how their trick. Determine the domain on which the function is decreasing. Okay, so starting here, it's going down. So x values less than or greater than -4. And don't get fooled because I'm going downward, it's x. What happens to x values as you move to the right? They get bigger. So the way they want it, I guess, is x is greater than -4. Oops, greater than, Hardy. You got to get the greater sign in there. Greater than -4. I still would take -4 to infinity. I just don't think DeltaMath is going to. All right, now Hardy's getting irritated. Determine the domain on which the following function is decreasing. Decreasing. X is greater than 4. So you're getting to see this with me live as I'm looking at some of these going, I may just not put this on the test now that I see this. Okay, let's find out how they want it written, because we thought we had this figured out with them. Did I put a period in with mine? Oh, for the love of Pete. That's it. So we were supposed to put x is greater than -4. I just put a period. Okay, sounds good. I can see why some of you get flustered with this stuff. Okay, end behavior. Which is the end behavior? Now remember with these. Okay, x, we're always going to have negative infinity and positive infinity. Those aren't going to change. So it's really just the y's that we're looking at. So as x approaches negative infinity, as x is on the left, actually I'm going to draw this on a piece of paper. I want you to be able to see what this looks like. So hang on a minute here. Okay, so I'm just going to do a quick sketch. Okay, so here's what we're asking. As x goes to the left, okay, is that arrow going up towards positive infinity or down towards negative infinity? That's all you're being asked. So as we're going towards positive infinity, our y, as we're going up, okay, let me do it this way. And they're using y, aren't they, instead of f of x. Oh. Okay. All right. So as x is going left, okay, this is the left side of my graph. That's why I circled here. Is this arrow going up towards positive infinity or down towards negative? It's going up towards positive. okay? Then, as my graph goes to the right, okay, here's the right side of my graph. Is this arrow going up towards positive infinity or down towards negative? Down towards negative. So this is what I'm looking for, this pair. So let's see here. Negative, negative, no. Negative, positive. Negative for x, positive for y, yes. Positive and positive, nope. Still looking. Negative x, positive y, positive x, negative y. That's the one we want. Ooh. And so this last one, I look at the same thing again, okay? We know the x's already, it's just the y's. What's happening to y in both of these though? Down to negative infinity, down to negative infinity. So I just got to find the one where both y's are negative infinity, because the x's are all going to be the same on these. Negative and negative. Okay. Here's the bottom line, okay? Now, we had some bumps in the road on a couple of things here, and I'm going to look into those going on to the test. I'm even going to try and get some of the review stuff fixed up here a little bit. Here's your forewarning on the test, okay? I am going to try and reduce the cheating to an absolute minimum on this. Now, it is not cheating to use your notes. It is not cheating to use your worksheets. It is not cheating to take notes from this review and have them ready for the test, okay? I'm not going to give you days on end, though, once you start this. So this test itself, like I said, is going to be about half this size. It's going to be about 15 questions. There is going to be a 1-hour time limit once you start, okay? So work through the review, have your questions ready, jot down your notes on what, the answers are supposed to look like, whatever it runs. It's going to run approximately in the same order, okay? And I'm going to triple check the questions to make sure everything's good before we get going. But once you start that test, make sure you've got a time that you can sit and do it, okay? Now I'm going to give you an hour. I don't think it's going to take you an hour. I think it's going to take you about maybe 30 minutes, okay? Give yourself that time, give yourself that ability, because this can help you out a lot, okay? But if you have more questions on the review, let me know. Thanks for working with me today.